then your homework should be quick, and then if you need time to work on the homeworks from the last 2 days, that's okay. We're going to talk about growth versus decay. So it's going to be exponential growth when your base is greater than 1, and it'll be exponential decay by, thank you, if your base is less than 1. Okay? Your growth parent function is going to be y equals 2 to the x. And your decay function is going to be y equals a half to the x. So, obvious difference there being one of them the base is bigger than 1, base 2. The other one the base is smaller than 1 because it's only a half. Okay? So, if you were to graph these in the calculator, do y'all remember from Algebra 1 what exponential growth looks like? It's okay if you don't. It goes up on one side. So put a dot here at 0, 1. And then on the right side, your graph is growing. Okay, so this way. But on the left side, your graph is going to be getting closer and closer and closer and closer and closer to the x-axis. Now, it doesn't ever get there. What's that called? An asymptote. What kind? Horizontal or vertical?
Horizontal.
Okay, very good. So this is a horizontal asymptote on the x-axis. Okay? So if I wanted to write the x-axis, I would say y equals 0 because it's approaching 0, but it doesn't ever get there. Now notice it only has the asymptote on one side, not on both sides. Okay? My domain, if this arrow is pointed to the left forever, and this arrow is pointed to the right forever, my domain is going to be all real numbers, you got it. But my range is not going to be all real numbers because my graph is never allowed to cross this line. So what y is that if it's the x-axis? How high would that line be if it's the x-axis? 0. Now remember that normally numbers would get brackets, but because it's an asymptote and I never actually touch 0, that's why you would still give it a parentheses. Okay? Alright, look right next to it, please, at exponential decay. Okay, sketch a graph for me. Your graph is still going to go through 0, 1, right here. Okay, but the difference is that decay is basically that graph, but backwards. So it's going to come down on this side, and then it's going to keep going down, basically approaching the x-axis as you go forward. Okay, so this graph also has a horizontal asymptote at y equals 0. Okay, because remember, it's going to approach 0, but it will never get there. Never hit it. Okay? So it's going to get closer and closer and closer to 0, but it's going to never actually get there. Okay? That's what an asymptote is. Then my domain is still all real numbers. And my range is still 0 to infinity. Okay, and remember, the reason why those are pretty much the same is because the graph is flipped around, but it's still going up forever on one side, going down forever on the other side. The only difference is which side it happens on. Okay? Alright, so come down to the bottom. We're going to set up our general equation. So the goal for today is just for you to be able to sketch graphs of these, which we've done before. So it would be y equals ab to the x minus h plus k. And literally all of these letters do the exact same jobs that they did when they were square roots, when they were asymptotes, when they were parabolas. It doesn't matter. Okay, so the stretch is going to be when a is greater than 1. A compression is when a is less than 1. Okay, so greater than 1, less than 1. That's the difference for a stretch versus a compression. That's this number right here. Okay, then the x minus h. Okay, that is going to determine whether you go left or right. And then the number at the back is going to determine if you shift up or down. Okay, now remember that whichever the X is, that's the one that's always backward. So if it's a plus, you're actually going to the left. If it's a minus, you're actually going to the right. Okay? Then it says here, when graphing, the coefficient A determines how far the point is for the horizontal asymptote. We'll talk about that in a second. Now, on the parent graph, how far above the asymptote was that point? It was 1 above it. So what that means is that if your A becomes a 2, you're going to be 2 above it. If your A is a 3, you're going to be 3 above it. Okay, so flip over to the back. We'll graph a few of these. Okay, look at the first one. Okay, first thing that we're going to do is we're going to decide if it's growth or decay. Look at your base. What will this one be? This is my base right here. Is it bigger than 1 or smaller than 1 if it's 1.3? Bigger, so it's growth. Okay, then is it going to be a stretch or a compression? Okay, look at the number in the front. My A is a 2. That's a stretch. And then it's only going to be reflected down if there's a negative in the front, so this one is normal. Okay, now let's shift our graph. So look at the number with X up here. If it's a plus 2, which way am I really shifting? Okay, to the left 2 and then down 4. So left 2, down 4. That puts me right here. Draw in your horizontal asymptote. So my asymptote goes like this. And now remember that my graph doesn't ever touch that dot. It's going to touch 1 above that dot. So if my dot is here, my graph is going to go through that point. Actually, hold on. Normally it would go through that, but what's my A? Sorry. 2. So actually go up to 2. Normally it would go through 1 if there wasn't a stretch or a compression in the front. But since my A is 2 units because A is 2. Okay, and then from there, through that dot, you're going to draw your graph going up on the right side and down on the left side. Hello? Yes, I just sent him to go get his stuff. He said he didn't have it with him or something. Okay, as soon as he gets back, then I'll send him down. Okay, thanks. Okay, so on the right side you're curving up, left side you're going down towards that asymptote. Okay, so it looked like this. Up on this side, down on that side. Okay, then the only thing that's going to change, your domain is still going to be all real numbers, but your range is going to be shifted. Instead of being 0 to infinity, what is it going to be now? How low is our asymptote? -2 to infinity. So since I moved it down, that changes my range, but my domain is still going opposite directions. Okay, look at the one right next to it. Okay, first thing, what's my base on number 2? 10. And if it's 10, is it growth or decay? Growth, because it's bigger than 1. Okay, then look at the number in the front. It's also a 2, so that makes it a stretch. But the negative means that it's reflected. Okay, so my A is a 2 in the front. Let's actually change it to a 3 just so the graph can be different. Okay, so A is going to be -3. But remember, since 3 is bigger than 1, that's why it's a stretch. Okay, so let's graph our thing. Which way are we shifting? Up 6, and then are we going sideways if X doesn't have a number with it? We're good. We're only going up 6. So go up 6 to right here. Put your dot. And then remember, that's where your asymptote goes. That's not your actual graph. Now, normally my graph starts 1 above that. This one is going to start where? 3 below. Very good. Now, why is it below? Because it's reflected. Good. So I'm going to start here. I'm going to count down 1, 2, 3, and I'm going to put my dot right there. Now think about, normally your graph is here. So if I want to reflect that down, it's going to be here. Okay, this is a normal exponential growth curve, but it's flipped upside down to be upside down. Okay, your domain, what would that be? It would be all real numbers. Because remember, it's still extending to both sides, but my range is going to be different. Instead of being from the asymptote up, now it's from the asymptote down. So I would have to list negative infinity first, and then 6 second. And remember that when you're doing asymptotes, they're always parentheses, because you're never actually getting to that line, you're just approaching it. Okay? Alright, go down please to the last two. So the top two were both growth, the bottom two are both decay. So take a look at number 3. My base here in the middle is a 0.2. That is decay. And then the number in front of that is your stretch or your shrink. So if it's a 4, that's going to be a stretch. And remember, that also tells me how far away from my asymptote my very first point is going to be. Okay, will this one be normal or reflected? Normal. Good. Okay, so let's graph. Where are we shifting? I have a +6 up top and a -2 on bottom. Yep. Good. Left 6, down 2. So do that first, right there. Draw your line in. And then from there, normally I'm 1 above. In this case, I'm where? 4. Above or below? It's only below if it's a negative in front, so this one would be above. So 1, 2, 3, 4. Put your dot right there. Now, before you draw it, this is decay. Remember that decay goes towards 0 going forward. So you're going to start up high and then cut through towards 0 on the right side, because this is decay. So the big difference is which side they're getting closer to the asymptote on. Decay is going forward towards the asymptote. Growth is going backwards towards the asymptote. Okay? Domain would still be all real numbers. And your range, how low is this line? -2, right? So it'd be -2 till infinity. And remember, it's -2 to infinity because you're above that asymptote versus being below it. Okay? Take a look at number 4 for me, please. Okay, my base is a half. This is always your base. And if my base is a half, that makes it decay. Then I have to decide if it's a stretch or a compression. I look at the number in the front. If A is a -2, 2 is bigger than 1, that makes it a stretch. Okay, then normal or reflected, this one is going to be reflected. Good. So then I'm going to identify which way we're shifting our graph. If it's a +3 up top, that means we're actually going to the left 3 and up 7. So I'll go to the left 3, up 7, puts me right here. And then remember, that very first dot is where your asymptote goes, not where your graph goes. Now, normally the exponential graph starts up 1 from the asymptote, but because my A is a 2, I'm going to be 2 away, and because it's a -2, I'll be above or below which one? Start below 2, very good, so that'd be right here. Okay, now this is where when these are flipped, it can get tricky. Okay, so think about, this is my normal decay, right? So if I flip that, it's going to end up looking like this. Okay, because it's upside down. So remember that decay usually starts high and ends low, but since it's upside down, that's flipped. Okay? Then my domain is still all real numbers. And then my range, I have this arrow pointing down towards negative infinity. That's going to come first. And then I have this side approaching 7. And even though that's a number, since it's an asymptote, you give it a parenthesis. Make sense? Easy? Okay, so take a look at your homework. And then if you don't have your homeworks 1 or 2 from yesterday or the day before finished, you can work on those. If you were absent one day, they're on the YouTube channel, which is on my website, if you need help with that. They're also, they've been sent on Remind 101. Okay.